Stellar black hole. A stellar black hole is born when a massive star dies. For millions of years, the star burns through its fuel. Then the fuel runs out. The core collapses. In less than a second, the mass of multiple suns crushes into something smaller than a city. The outer layers explode outward as a supernova, one of the most violent events in the universe. But here's the disturbing part. The explosion is not the terrifying thing. The thing left behind is. A stellar black hole is small enough to hide inside a city, yet massive enough to dominate an entire solar system. Near its event horizon, gravity becomes so extreme that escape becomes impossible. No spacecraft, no signal, not even light. Cross the boundary and the universe loses contact with you forever. And that's what makes these objects so unsettling. Scientists estimate the Milky Way may contain around 100 million stellar black holes. Most are invisible, silent, hidden between the stars. You could pass near one and never knew it existed until it was too late. But stellar black holes are only the beginning, because the next type doesn't control a star system, it controls an entire galaxy. Supermassive black hole. At the center of the Milky Way, something invisible controls everything around it. Sagittarius A star, a black hole containing 4 million times the mass of the Sun. You cannot see it directly, you only see its influence. Stars racing around an apparently empty region of space, entire solar systems trapped by a force hidden in darkness. And here's the unsettling part. Our own solar system is orbiting it right now, at more than 200 kilometers per second. One orbit around the galaxy takes roughly 230 million years. The last time Earth occupied this position, dinosaurs had not yet appeared. Human civilization was still unimaginably far away. Suddenly, Earth feels very small. But then something changed. In 2022, astronomers captured the first direct image of Sagittarius A star, a glowing ring of superheated gas surrounding perfect darkness, a ring of light around a place where light dies. And that image revealed an even bigger mystery. Sagittarius A star is actually considered small. Some supermassive black holes contain billions of solar masses. They dominate entire galaxies, yet many appeared far earlier than current theories say they should have. They grew too quickly, too easily, as if something about black holes remains hidden from us. But even these giants are dwarfed by what comes next, because the next object is so large that entire solar systems disappear inside its shadow.
Ultramassive black hole. This is where scale begins to break. Ultramassive black holes contain tens of billions of solar masses. The most famous is TON 618, one of the largest black holes ever discovered. Its mass is estimated at around 66 billion suns. If it replaced our Sun, every planet in the solar system would be trapped inside its event horizon. Mercury, Venus, Earth, Mars, Jupiter, Saturn, gone. Not destroyed, simply trapped beyond the point of no return. Its event horizon is so enormous that light would need weeks just to cross it. Weeks, traveling at the fastest speed the universe allows. And here's the mystery. TON 618 existed when the universe was still young. According to current models, it should not have had enough time to grow this large, yet it somehow did. Scientists still don't know how. And that raises an uncomfortable question. If black holes can become this enormous, how much larger can they get? Because the next black hole may not have formed from a star at all. It may have formed before the first star ever existed. Primordial black hole. A stellar black hole forms when a star dies, but a primordial black hole may have formed before the first star ever existed. Before galaxies, before planets, before anything recognizable. Moments after the Big Bang, the universe was an ocean of pure energy. Space was expanding, reality was unstable, and tiny fluctuations rippled through the newborn cosmos. Most disappeared, some grew. But here's the disturbing possibility. Some regions may have become so dense that they collapsed directly into black holes. No star, no supernova, just gravity acting on raw energy. Reality folding in on itself.
And that changes everything, because these objects could be older than every galaxy we have ever observed. Some may be smaller than a grain of sand, yet weigh as much as a mountain. Ancient relics drifting through the universe since the beginning of time. And some scientists believe they may still exist today, invisible, silent, passing through space unnoticed. But if black holes can survive since the birth of the universe, what happens when two of them collide? Binary black hole. Two black holes, one orbit, and a collision powerful enough to shake the universe. A binary black hole forms when two black holes become trapped by each other's gravity. For millions of years, they spiral closer together, slowly, relentlessly. Then, reality starts behaving strangely. As they orbit, they generate gravitational waves, ripples in space-time itself. Not light, not radiation, actual distortions in reality. In 2015, humanity detected one of these signals for the first time, a message from two colliding black holes over 1 billion light-years away. The event lasted less than a second, yet during that moment, more energy was released than all the stars in the observable universe combined. Then, silence. The merger was over. Two black holes became one. A larger predator emerged. And that's the unsettling part. The biggest black holes in existence may have been built through countless mergers like these, growing larger for billions of years. But not every black hole stays where it was born. Sometimes the universe throws one away. A Kugelblitz. It's a theoretical black hole made entirely from light. No dead star, no collapsing matter, just pure energy compressed into an impossibly small space. According to Einstein, energy and mass are different forms of the same thing. If enough light is concentrated into one region, gravity wins. A black hole forms. Which means light itself can become darkness, a place where even light cannot escape. And that may be one of the strangest ideas in physics, but the final object is stranger still, because it may expose something the universe was never meant to reveal. Naked singularity. Every black hole hides its deepest secret behind an event horizon, a boundary beyond which nothing returns, a curtain hiding whatever exists inside. But what if the curtain disappeared? That is the idea behind a naked singularity, a theoretical object where the most extreme region in the universe is exposed directly to reality. At the center of every black hole lies a singularity, a place where our understanding of physics breaks down, where space and time stop behaving normally. Normally, the event horizon keeps that region hidden forever, but some models suggest the horizon may not always exist. The singularity remains, the protection does not. A wound in reality itself, open, exposed, uncovered. No naked singularity has ever been observed, but nobody has proven they are impossible. And that leaves a disturbing possibility. Somewhere in the darkness of the universe, there may be places where the laws of physics are visibly broken, and nobody knows. From stellar black holes born and dying stars, to primordial relics older than galaxies, from collisions powerful enough to shake space-time, to invisible wanderers crossing the galaxy, from quasars bright enough to outshine galaxies, to naked singularities where reality itself may break apart. One truth remains. We are not just studying black holes, we are studying the edge of reality. Because beyond every event horizon lies a place forever hidden from the rest of existence, a place where our knowledge ends and the unknown begins. If you enjoyed this journey into the darkest objects in the universe, subscribe for more deep space documentaries exploring the mysteries science still cannot fully explain. Because the deeper we look into the cosmos, the stranger it becomes, and sometimes it feels like the darkness is looking back.